Right, this time we've got 3 separate groups of terms and they're all got A, B and C in them. So there's never going to be a duplicate unless someone's written a question wrong and they're going to put A, B, C again, which would be a bit daft. So there is going to be some grouping that we can do. So we can use the distribution rule. So whenever you say anything like this, where you say, like, well, I've got A, B, C there, I've got A, not B, C, so there's some common stuff there, and there's some common stuff there. So I'm going to group again. So I'm going to pull out common factors. So I'm just going to grab and look at these two. So I've got A, B, C, and then I've got A, not B, C. So there's 2 common terms between those two. Can everyone see that? There's A and C. So I'm going to say A and C. Okay. I can do that, or I can just pull out the A. So I could do this, and then I can put in here B, and not B. Okay, so I've pulled out a common term, and then I've got B and not B. So what can I do to B and not B?
1.
Would B and not B be 1?
Yeah.
And?
Oh,
Go on, Connor. It'd be a 0. Okay, so we cancel out completely. So that would be 0. Okay, I think I've gone completely wrong without I've approached this one. I don't know what I did on the sheet. I didn't look. What did I do on the sheet? Have I gone and put the wrong thing down? Oh yeah, of course it is. Yeah. Because of that, that's what I'm doing. Okay. So I've got, if you multiply this back out, you should see I've got A, C and B. It's just like maths. It's just like if you've got X and then you've got Y plus Z. If you multiply that bracket out, you get X, Y plus X, Z. That's all this rule is. Just expanding and closing brackets down. Okay? Right, so actually, Callie, you were right, and it is 1, if I'd have written the right symbol down. But that's how easy it is to make a mistake. Okay? K-maps are easier because you can't make those mistakes. It's the same old story when you're writing down maths. Alright, so yeah, that simplifies to 1. So we actually end up with, that lot breaks down to A and C. Now, if you look at what we got with the Carnot map, we look like we're close to an answer. Okay, but we're looking for AB. So let's bring down the rest of it to see what we've still got left. Okay, is there anything common again? A? A's in both. So we could pull an A out. Which pen works better. Right, so Callie, what's inside the bracket then?
Is it B,
Keep it in the order that it's already in.
C?
Right, so we got a C there. Yeah. Or.
B,
Yeah.
not C?
Yeah. Right, it is algebra. It's called Boolean Algebra. So we've actually got that term and this term left. Now that actually doesn't look any simpler, just looks more complicated, but this is where the absorption comes in. Okay, if you look at the absorption rules, now they're all represented by X's and Y's and things, so they don't look like this, but we've got, I can't remember the rules, but I can see a pattern. I have got here something that is normal, I've got C, ored with something else, some other term, but the not of that. Now that is one of the absorption rules. Okay, there's a massive bit of cancelling out that goes on. So which absorption rule do we use and what does it reduce to? It's one of the bottom 2, I can't remember which. this will always, if you've ever got something like this where you've got a normal and a not with 3 terms involved, it'll always reduce down to 2 using absorption. Which one is it? It's one of the bottom 2. I can make it easier if I rearrange it using one of the other rules, which is distributive. So if I was to write this with a pen that works, if I just rearrange this, so I say, right, okay, I can actually write this as not C and B, and that doesn't change anything. Which rule is it? What does it reduce to?
D, just B.
It's what?
It reduces to just B.
No, it reduces to 2 terms.
C and B.
Right, so there is one that looks like that one. There's one that goes, if you've got something odd with the opposite of it, that's handed to something, it does become that. Yeah? Right, so that's gone a bit untidy now. So we started with A out of the bracket. So we had A and, are you sure it's and not or?
Yeah, I think that's all.
Yeah, it's or. It generally, that one stays. So we've ended up with C or B. Now that doesn't look like that because this has got brackets and it's all ready to be multiplied out. So let's just use the distributive thing again to say, right, okay, that's A times C. So A and C, or A and B. Ooh, that's what we had in the Carnot map. Those 2 rules, the distributive one where you're looking for common factors, effectively, and the one where you're always looking for silly, weird things like this that look hideous, but they'll always reduce through absorption. Now, on the back of the Boolean Algebra sheet, because the absorption rules are weird, I actually did truth tables to show you that they are true and they're not just made up. Okay? But it is the absorption rule that gets you out of lots of horrible situations. If you can do the common factors, you're looking for trying to get a common factor that leaves you with something that cancels out, that reduces. Okay? Right. Let me stop that one.